So this is going to be kind of like a little review. If you were here that Friday before break, today is the day to pay attention. Okay, if you were here, great, fabulous. You're just getting prepped for your mastery check tomorrow. Okay, so what does the 3,000 represent in this expression? Where's the 3,000? Say again. Yep, initial value or starting price. What does the 2 represent? The number of years. Okay, is this growth or decay?
Growth.
Why?
Oh, decay.
Why?
Oh, I see negative.
Okay, we got subtraction in the middle. Okay, so that's going to be decay, right? Another way to do this is saying 1 minus 0.06 is 0.94. Is that less than 1? Yes, so that's going to be decay, right? So what is the rate of growth or decay? Well, the rate is whatever this number is that we're subtracting. So 0.06, or you could say 6%. Okay. Now you're going to take a moment and you're going to type this into your calculator because it says evaluate the exponential expression. Okay, so take a moment, plug that in. Okay. All right, what did you get? So you type this into your calculator. What'd you get? Oh my goodness, 2,600. Point. Is it 2 decimal places? No, just 0.8. Okay. Remember, when we're dealing with money, we went around to 2 decimal places. So even if it says like 0.8, you're going to add that 0, right? Okay. Questions on that? Hopefully that was a review. If it wasn't, hopefully you learned something. So we're going to continue to write exponential equations that represent both exponential growth and decay using real world context. Okay, so you've inherited land. Congratulations. That was purchased for $30,000 in 2000. The value of the land depreciated by approximately 5% per year. What does depreciate mean? Decrease. So we're going to write an equation that models the value of the land as it relates to time that has passed. So we're going to say value of time. And how much did we start with? 30,000, right? And we're going to say depreciate. That's going to be 1 minus. So everybody sees the initial, and then we're saying 1 minus. Okay, and we're going to say 0.05. The reason why we're going to say 0.05 is because we move that decimal place over 2 spaces. And then we're going to raise it to the t power. I'm a big fan of steps. When I do this, in my head, I literally think, find your initial amount, which we did, which was 30,000. Then we decide whether it's growth or decay. So that's going to decide whether or not it's 1 plus or 1 minus. We change our percent to decimal. And then we raise the parentheses to the t power. So these are kind of like the little steps that I use when I write out these equations. You don't have to write that down, but if that helps you, you can. What is the approximate value of the land in the year 2023? Please do not plug in 2023 into the equation. What are we going to plug in? 23, because we started at 2000 and then got to 2023. So we're going to say V of 23 is equal to 30,000 times 1 minus 0.05 and raise it to the 23rd power. Go ahead and take a moment and type that into your calculator. All right, so what'd you get? There you go. 9,200 point. Okay. Questions? Okay, on your mastery check tomorrow, one question will look like this, where it'll basically say write the equation and then plug some arbitrary number in. Cool? Okay, so let's look at the next one. All right, in the last 12 years, an initial population of buffalo, 38 buffalo in a state park grew by 7% per year. Okay, use the table to help write an equation modeling the situation. All right, so the initial year we had 38 buffalo. How many do we have the next year? How do we write the equation? Well, what's our initial? And are we increasing or decreasing? We're increasing because it says grow. And we're going to grow by 7%. So we're going to change that to a decimal. We're going to raise it to the t power. For each one of these years, you're going to take this number and you're going to plug it in for t. Okay, so go ahead and take a moment, see if you can fill in these 3 spots. Okay, so when you plug this in, I think you get like 41 on the first one. And then it's like 44 on the next one. And then the last one's like 47, right? Remember, we can't have half a buffalo. So you got to round somehow, right? So it's 47. Now, whatever they say for t, all they're asking you to do is just write this equation out. So they're asking you to say 38 times 1 plus 0.07 for raising it to the t power. That's it. And then it says, using the equation you created, determine how many buffalo there are after 8 years. So all you're going to do is plug in, let's do 8 in for t. Take a second, type that into your calculator. And how many buffalo did you get? I think it's 65. Okay. Questions on that? On your interim, they sometimes ask like table. On your EOC, they sometimes ask table. So you really need to be comfortable with this table and the equation, okay? Let's say they don't give you any of this junk. They just give you a table that's filled in. How would you write the equation? Okay, so let's say it again. They don't give you any words. They just give you this table. How would you write the equation? What would be your initial? Why do you know that it's 38? Okay, so it's year 0. So this is my initial, right? How do we find the rate now? Yeah, but how do we find it? Second number divided by the first. Take 41 and divide it by 38. Type that in your calculator. What number did you get? And look at what we have right here listed in the parentheses. Yeah, 1 plus 0.07. There it is right there. So we can write our equation even though we don't have the words written out. Yes? We okay on that? Okay. Okay, so just a reminder, we've talked about this already, but again, we've got growth and decay. These are the same equations. They really are. This is called simple interest. Okay? Go ahead and take a moment. Go ahead and answer this question. If I tap it one more time. Go ahead and answer this question on your paper. So Tony the Tiger has 4,250 followers on social media. His number of followers is increasing at a rate of 3% per week. Which function represents the number of followers each week? So the reason why B and D are the most picked answers is because you got that 0.03, right? Now, this 0.03, is that growth or decay? That would be decay. Is this growth or decay? Okay. And what is he supposed to be doing? Okay, so it should be D. Does that make sense? Obviously, you can plug into your equation. That's fine too. Okay. All right. Go ahead and take a look at the stick it together, interpreting inequalities in context. We started working on this a while ago. You might have it in your book bag, but I want you to start fresh. Okay, so you can work with a partner or you can work in a group of 3. I'm gonna give you about 15 minutes to work on questions 1 through 5. So there's the front and back. Okay, when you have answered all 5 questions, up here on the board, right here, like actually on the physical board, okay, there are the answers. So you can check your work, okay? You must come to a consensus before you go check your work. If you have a question about something, you're gonna come see me, okay? But you must finish all 5 questions,
Together.
okay? Yes. All right, okay. How many of y'all have eaten Tootsie Pops? Know what those are? It's like the sucker that has like the chocolate in the middle, right? Yeah? No, just me. Okay. How many of y'all have eaten a blow pop before? Yes. Okay. How many of you actually like within like the first 30 seconds of you actually getting like the blow pop, it's like gone. Like suckers are supposed to last, right? And instead, like you just bite it, right? Yes, that's me. I can't do like more than like 20 seconds. But anyways, so for her 8th birthday, this child is 8 years old. Shelly's grandmother gave her a full bag of candy. Shelly counted her candy and found out that there was 160 pieces of candy in this bag. As you might suspect, Shelly loved candy, so she ate half the candy on the first day. An 8-year-old, y'all. Her mother told her that if she eats it at that rate, the candy is only going to last one more day. After hearing this, Shelly devised a clever plan. She will always eat 1/2 of the candy that is left in the bag each day. She thinks that this way she can eat candy every day and never run out. Okay, so we're going to create a table based off of this scenario. So on day 0, how many candies does she have? 160. On the next day, how many does she have? Because we're eating half, right? On the next day, how much do you have? On the next day, next day, next day, next day, 2.5, next day. Okay, so after 7 days, Shelly's gonna have 1.25 candies, right? Now let's actually write an equation based off of this. So how much did we start with? Our initial. Okay, and then we got 1 minus, what's our rate that we're going down by? What are we going down? Half. Okay, and we're going to raise it to the t power. If we actually simplified this, this would be 160 times 0.5 raised to the t. That's what we've seen before, right? Now, will the candy really last forever? But wait, on day 8, how many pieces of candy does she have? On day 8? Point, what? 0. $6.25. Okay, on day 9, how much are you gonna have? On day 20, how much candy is she gonna have? How do we figure that out? You plug it into the equation. Okay, so that's gonna be 0.5, and we're gonna raise it to the 20th power. Multiply that by 160. That's 0.00015. How much candy is that really? Like this. Like crumbs, right? So is the candy really lasting forever? Not really, right? Okay, so no. And what's another thing about candy? What does every package in America with food have on it? Expiration date. Okay, there's an expiration date, and at some point, she shouldn't be eating that candy, right? Expiration dates. So, no, the candy won't last forever. Now, the math will tell you otherwise. The graph will say, hey, she's going to eat 0.00015 of a candy. I don't know about you. That's not physically possible in my book. Okay. Cool. Okay. All right. So go ahead and take a moment. I want you to look at the document that says agree, disagree. Okay. And this is kind of like a, do you understand what's going on type thing. I want you to agree or disagree on this document and tell me why. I'm going to give you about 8 minutes. Okay, this is what I got. Again, this is just a, hey, do you understand what's going on? Okay, on this one, This one always trips people up, but this is going to be disagree. It's going to be agree, agree, and disagree. Reason why is because this guy up here goes up by 2 days each time. So if you plugged in 2 into the equation, it wouldn't give you 6. Okay. Down here at the bottom, this should have been 1 minus 0.05. 1 minus 0.05. So that equation is incorrect. Okay. How many y'all got 100 on that? 75? Okay. Cool. All right. So we're going to move back to something that we kind of were talking about a little while ago. All right. Y'all are going to want to go back to your seat for that one. This one. Y'all have this? No, y'all don't. Which one's different from the rest of them? Investment 3, why? Because the interest rate is different. Okay. You could have came up with anything. You could have said investment 2 because it has the highest initial. Investment 1 because it has the lowest. Okay. All right. So we're going to talk about simple and compound. What's the difference? Okay. So use the investment 1 through 3 to answer the following questions. Investment 1 and 2 have the same interest rate. Does this mean the investments will increase by the same amount each year? Why? They have different starting amounts. Okay, so let's think this one through. Let's make like a little table. Okay, so we got investment 1, 1, 2, 3, and we start with 100. Okay, and then we got investment 2, and we start off with 400, right? Okay, can you find these next 2 spots? Can you find these next 2 spots? So for our equation, it would be our initial 1 plus 0.05. For this one, we would have 400, 1 plus 0.05. Can you plug in 1 and 2 for these exponents? Take a second. So when you type this into your calculator, what'd you get? Huh? 105. And then what was the next one? 110. All right, what about over here? 420. And then what was the next one? For what? 440. Okay. All right, so are they increasing by the same amount each year? Well, this one's going up kind of by like 5-ish or 5%. And then this one's going up by 20, right? They're going up by the same percentage, but not the same amount. Okay. So how much will each investment increase by each year? So investment 1 is about $5 each year. Investment 2 is about $20 each year. Okay. Now it's not going to be the exact same. Yes, ma'am. It's not going to be the exact same amount each year because we're doing investment or we're doing percentages. Okay. All right, let's go ahead and look at the next one. How can you represent the investment 2 as a formula? We've already kind of talked about this. Here's our formula. 400 times 1 plus 0.05 raised to the t. 400 times 1.1 plus 0.05 raised to the t. How do you know that these represent compound interest and not simple interest? How do you know that these represent compound interest, not simple interest? How can we tell? Okay. So compound interest looks like this. And simple interest looks like this. So what's the difference? What's the difference? The equations are different. What is this in? What does that in represent? Number, so the number of times that it was compounded in a year, right? So we would say monthly, biannually, semi-annually, etc., right? So how do we know that this represents compound interest? What would our in have to be to make these compound interests?
Wait, we go up in time.
Sorry. In would have to be 1. Watch this. If I have this formula, but I put a 1 underneath that r, and I put a 1 in that exponent, if I simplified this, it would look like this. What does that look like? Yep. Simple interest is compounded annually. Okay, that's why these look similar. Okay, so this is happening annually. Okay, they're also very small investments. Look at the investment number. 500, 250, 500. If you did simple interest with that, you'd make 0 money. Like you just wouldn't make enough. Okay, compound interest, that means that it's happening monthly or it's happening biannually, etc. All right, on part 3, what is the initial investment on investment 3? 500. How long is the money invested for? 2 years. And what was the interest rate? 3%. Okay, and the way she got 3% is she said 1.03 minus 1. That gives me 0.03. I'm going to change it to a percentage. All right, so back in the day, in the 90s, what people would do is they would buy a savings bond for their kid. Okay, and what these would do is you would essentially buy it from the government, and you're giving money to the government up front, but then they're going to pay interest back to you. Okay, so parents used to buy this for their kid, and then when they turned a certain age, they would cash in the money, and that money would gain interest, and there would be a lot more. So my parents bought a savings bond that was $100 when I was a baby. By the time I was 18, it was worth $1,500. Okay, and so I use that for college. That's what people would do. Okay, now those aren't used quite as much anymore, because we're in debt, but it's not that big of a deal. It's fine. Okay, so a family has $1,000 to invest, and it's considering 2 options: investing in government bonds that offers 2% simple interest, or investing in a savings account at a bank, which charges $20 to open and 2% compound interest. Both options pay interest annually. Here are the 2 tables showing what they could earn in the first couple of years if they do not invest any additional amounts or withdraw any money. Okay, so how does the investment grow with simple interest? Okay, so looking at this, it's going up. So it's going up by roughly $20, or you could say 2%. Okay, now the savings account for this one, how are the amounts calculated? How are these amounts calculated? Well, let's write an equation for this. Okay, so this is talking about the savings account. So looking up here, it says charges $20 and then it pays 2%. So why did we start with $980? Why did we start with $980? Not that it starts with 2%. What else did it say about it? It charges how much to open? $20 to open. So we're already $20 in debt just from opening this account, right? So we're going to say 980, 1 plus, how much are we going up by each year? 2%. We're going to raise it to the t power. So these are found by plugging in 1 and 2. Now, number 3, it says, give a description of what the domain and range presented in the table represent. For our domain, what does that represent? Yep, number of years. And our range represents what? Amount of money. Okay. Go ahead and write an equation for the bond. Go ahead and write. Okay, so this should have been 1,000 times 1 plus 0.02 raised to the t. Okay. Now remember, it does say that this one is compound interest. Okay, so looking at this one right here, we would actually divide this by 1 and multiply this by 1. Okay, because it's saying that it's happening annually. Okay. All right, flipping over to the back, what type of function is each one of these functions? What type of function is each one of these functions? Is it linear, quadratic, or exponential? Exponential, because we got an exponent. That is a variable. Okay. Now, on the next one, it says find the average rate of change from 0 to 4. So back on the previous page, you're going to fill in this table. You're going to find when x is 3 here, when x is 4 here, when x is 3 here, and when x is 4 there. So go ahead and fill these tables in using your equation. Take a moment, try that on your own. So when you fill this in, these are the numbers I would have got. Okay. Now you're asked for the average rate of change. Okay. So now just a reminder for average rate of change, that's going to be y2 minus y1 over x2 minus x1. Okay. And so looking at this first column, this would be x1, this would be y1, this would be x2, y2. We're going to take all of that and plug it into this formula. So that's going to be 1082.43 minus 1,000 over 4 minus 0. When you plug that in, you're going to get 20.6075. Take a moment, find the average rate of change for this column. All right, so when you found that, you should have gotten, I think it's 20.195. Okay. So which one has the bigger average rate of change? Which one has the bigger average rate of change? The bonds, right? Okay, so that means that they increase more quickly. They increase more quickly. Okay. So which one would you choose? The bonds or the savings account? I would choose the bonds because it would make me more money, right?